Hi, if you're seeing these solutions on YouTube, click on the description below, take these as a test and then check out the solutions for free.
Two similar pieces of square cardboard are arranged as shown below. The perimeter of the shape is 80 centimeters square. Find the area of the shape. And they're square, so they're similar pieces. That means they're congruent. This is similar mathematically. Sorry, not mathematically, similar in English. Two identical pieces. And the two pieces are exact copies of each other. Not similar as in similar triangles, similar squares. They are two identical pieces of square cardboard. And so this has sides A. This will have this other square will also have sides A. So what are we going to do? We're thinking about the perimeter. We're told that these are equal. So I'm going to say let the equal parts be A. Let this be A, this be A, this will be A, this will be A. So this side will be 2A, 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 2A. Now perimeter is 80 centimeters. Think about it. For the shape, perimeter is what goes around the shape. This is the shape because inside there is one square and this is another square. But we are not concerned about that. We are concerned about the shape. So this is 2A, this is 2A, this is 2A, this is 2A, this is A, this is A. Sum of all this is equal to 80 centimeters. 2A plus 2A, 4A, 6A, 8A, 9A, 10A. 10 times A is 80 or A is 8 centimeters, or the square has side 16 centimeters. Find the area of the shape. We need to find area of the shape. It's a wonderful question. This is a weird shape. We cannot have formula for the area of the shape directly. And that becomes very tricky to find. There are multiple ways of doing this. We can say, look, this weird shape can be carved into shapes that we understand. How do we do that? We can say, look, I'll draw a line like this. The rectangle. I'll draw a line like this. This is also a rectangle. So I can find this area and I can find this area. Now I'm dealing with the remaining part. I can draw this line. This is a right angle. This is a right angle. Add this and this to this and this. We are through. So A is 8. So area of this rectangle is going to be 8 into 10. Sorry, 8 into 16. A into 2A. This rectangle is going to be 8 into 16. These two are done. Now let's carve out this space right in between. This is A. This is 2A. So area of this triangle will be half into 8 into 16. Remember, A is 8. We've already found that out. Which will be nothing but area of this triangle. So adding these two, half into 8 into 16 plus half into 8 into 16. Which is nothing but both put together would be 8 into 16. Or we are looking at 8 into 16 plus 8 into 16 plus 8 into 16. 8 into 16, 16, 8, 6 are 48, 8, 4, 8 plus 4, 12, 128 plus 128 plus 128 square centimeters, which is 384 square centimeters. This choice. The other way of thinking about this, we can add area of this square to area of this square. This square to this square. Both areas we add. In both of those, this area is repeated. So we add these two and subtract shaded area, we'll get the overall area. Find the shaded area, draw this. We have two right triangles measuring 16 by 8. Half into 16 into 8 plus half into 16 into 8. This is area of shaded region. Subtract this from 2 times area of square. We're basically saying there are two squares that have an overlapping area. I'll add the areas of the two squares and then subtract the overlap, because overlap is counted twice. I'll add these two and subtract that. So the half plus half is 1 whole. 16 into 8 is 128. Subtract this from 2 into 16 into 16. This is 2 into 256 minus 128. 512 minus 128, which is 384. Absolutely wonderful, wonderful, wonderful question. We can think of it as breaking that weird shape into multiple components, 2 rectangles and 2 right angle triangles. Or we can say we add up the areas of the 2 squares and subtract the area that ends up getting counted twice over. Both approaches work.